Good afternoon, students. Now we discuss optical fibers. Before discussing this, fiber optics is a technology which transport optical energy from one place to another place through the optical fibers or glass fibers. So now we discuss optical fibers. So here an optical fiber as shown in figure. So an optical fiber consists of inner cell, in inner cylindrical which cell which is made of glass called the core. The core carries the light, which is the function of core. The core is surrounded by another transparent material of lower refractive index called cladding. The cladding helps to keep the light within the core through the phenomenon of total internal reflection. The core and cladding are shown in figure. The inner part is core, the outer part is cladding. See here in cladding, primary, secondary coating, primary coating, secondary coating. So here we have the following optical fibers: glass fibers, clad silica fibers, plastic fibers. So glass fibers, these optical fibers have glass core and glass cladding. Both core and clad made with glass. Here plastic. Here the core made with glass and clad made with the plastic fibers, both cladding and core made with the plastics. Now discuss the principle of optical fiber. So optical fiber has a transparent core with a refractive index N1 is equal to 1.7, surrounded by transparent cladding, slightly lower refractive index N2 1.5 as shown in figure. Here, so this is the core, its refractive index is 1.7, so the boundary is the cladding, so which refractive index is 1.5. So this refractive index is less than the refractive index of core. So when light ray is incident on one end of the fiber, at small angle, it passes through the fiber as shown figure. Let I be the angle of incident ray with the axis, and R is the angle of refraction. So theta is the if theta is the angle of incident ray which strikes at the boundary of the cladding, then theta is equal to 90 minus r, means so r plus theta is equal to 90, therefore theta is equal to 90 minus r. So here n1 is, let n1 is the refractive index of the core. So if this theta angle is greater than critical angle, so therefore theta c is equal to critical angle, where theta c is equal to sine inverse 1 by n1, sine inverse of 1 by n1. So then the ray is total internal reflected. Then the ray is totally internal reflected within the core. So in this way, the ray undergoes total internal reflected within the core and reaches to another end with 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 without loss of energy. So hence the optical fiber works on the principle of total internal reflection. Here the ray is totally internal reflected within the core. So here the angle of incident on the boundary of the optical fiber greater than critical angle, then the ray gets suffer total internal reflection. So this phenomena takes place until the ray reaches to another end without loss of energy. Hence the optical fiber works on the principle of total internal reflection. So thank you students. Now see the answer from starting to ending. Please students subscribe my channel. Don't forget. Don't forget subscribing.